I'm going to be running this webinar. My name is Thomas Andreasen, as Andres mentioned. I'm going to be running this, and we're going to be creating a project, or I'm going to be showing you a project from start to finish. It's the project that you can see on the screen right now. I'll run the animation, and then I'll explain the idea behind this animation and what it's supposed to show. Okay, let's start it. So that's it. And VLC is giving me a hard time sometimes. Just one moment. Okay, but you've seen it. It's a new version of VLC. I don't know what's happening. Okay, I'm going to be explaining the idea behind this animation that you just saw. Was that it was going to evolve around an art supply store. So when we make a TV spot or something for an art supply store, creating art is all about moods and colors. And with this project, I thought if we use the sound files, or excuse me, use the sound to let's see if we can get it up. Okay, no problem. That we use the sound to drive the animation and show various moods. That's, when you're painting or doing arts of some sort, you need, or you're in a specific mood when you're going to paint or going to do whatever you're going to be doing. And showcasing these different moods and materials in a very, it's a very short animation, and we needed to be able to show everything within this time frame of roughly 45 minutes. So the project isn't that big. Let's just look at it once more. I'll just open once more, even though VLC might not agree. So the first one here is orange paint, rather thin consistency. This is built with PPD particles or solver. Then we move on to completely different sound mood, and this is done with the viscous fluids, and move on to something that could be pastels or whatever you could be using. I admit these grains are quite large, but for the sake of demonstrating, I thought that was okay. And we move away from this and seeing that this is an artist palette, and the paint wells here are arranged like the golden, proportions, like the Nautilus shell has. So this is the animation, and then we have a drop, and the art supply store is called Nautilus. To keep it within the artistic realm here. So let's get on with it. Okay. First off, this project here, we'll open here. This is a model of the palette. this is when we're finished with this, after some days, you can get all the files used for this project. And I must say, this is not the most beautiful clean model, but it works. As you see, it's not very clean. Okay, but you can see here we have one collider here. I'll just turn off the palette, and we have this is just a model made from what's it called? I'm sorry, the oil tank object. So it's a model I've just made from this object, made editable and adjusted some of the polygons so we get this shape. What we are going to be doing now is filling this up with liquid or paint. And we'll go to the RealFlow up here. We have the RealFlow plugin menu, and we'll create a RealFlow scene. Okay, so nothing's happening right now, but we can see in the object manager here we have a scene tree or scene hierarchy with a few objects: meshes, emitters, fluids, and demons. And this is what RealFlow is using to create the particles and all the simulations. This is really the heart of working with RealFlow within Cinema 4D. Okay, so we have the scene file here. I'll just go and check my display tab here, because I'd like to get rid of the icon while we're working. Excuse me. Okay, so the first thing is that we need some particles. So I'll go up to RealFlow, emitters, circle emitter. So now we have an emitter, and let's just press play, see what happens. It starts to emit particles. No surprise here. Okay, I'll just make the time frame here a little shorter. Okay, so we have an emitter, it's emitting particles, and that's all fine. Two things, or several things, need to happen. First of all, we need to bounce the particles off this collision shape. To do that, we go out over to the collider, right click, go to simulation tags, RealFlow tags, and add a collider tag. And let's just press play again. As you can see, the particles are definitely colliding with the object, but it's behaving strangely. And that is because we don't have gravity. So right now it's like it's in space. It's being emitted from the emitter here in a certain direction, then it bounces off the shape here and floats out into space. So we need to add some forces to interact with these particles, and this is done by adding one of the demons here. We'll go to the gravity demon. Okay, let's see what this brings us. Okay, something is definitely better now. So we can see the particles are falling down. I hope you can see it on the screen as well as I do here. I'll just pause it and go up here. I'll go into the fluid. I'll explain shortly. Okay, so now we have larger particles. Okay, so it's a little bit easier to see what's going on now. So the particles, I'll just go one frame at the time, are falling down into the well and being bounced off this shape until it reaches the edge of the shape, and then it falls down. Okay, so this is the beginning. So let's just check out what's really in this scene hierarchy here. First of all, we have the master object here. This contains parameters for the solver calculation. So if we need to fine-tune some of the calculations to be more precise or faster or whatever, this is the place to do it. It also has a cache tab here, and we are going to be using that to cache the simulation. So when we play back and forth in the viewport here, we don't need to re-simulate every single frame, so we can cache the particles. And then it has a display tag. But let's just go back to the solver here, because we can see the speed here. That's quite alright. But let's go into the fluid here and just set the resolution up 200 and press play. It really starts to take quite a bit longer. But with the new version here of RealFlow for Cinema 4D, we have the option, I'll just go back, we have the option to use a GPU, so the graphics card for calculations. And I've got a pretty powerful machine here. I've got a GTX 1080, and if we press play now, we'll see that it goes quite a bit faster. Okay, so we can use the GPU for a simulation. That's a big plus. Okay, but that was the scene object here. The emitter, as the first item I added here. Excuse me. If I'll just go up here, if you look here at the list of emitters, we have quite a few different emitters. I added the one that was most suitable for this this project, the circle emitter. But you can, when you have the emitter here, you can change it to any of the other types of emitters. But I went for the circle emitter in this case. Okay, so this is the first step. This emitter just emits particles, but to get the fluid going and to adjust the amount of particles and the type of solver we're going to be using, like the PBD and viscous and granular emitter or solvers that we're using, we'll have to go down to the fluid here. So the fluid is the resulting fluid from the particles that are being emitted. And in this case, it's using a liquid PBD, and the PBD files are rather fast to calculate. The SPH files, or the SPH solver, takes a while longer, but they're more precise. So for really intricate simulations, you might want to go with the SPH, but for this case, the PBD worked perfectly well, and that was what we're going to be using because it's much faster. And in here, in the fluid, we set the resolution, which is the density of the particles, or the amount of particles we have here. And if we looked at the initial animation, we needed to fill up. Let's go back here. We needed to fill up this cavity here with a liquid, because we're going to be using this collision shape to bounce up and down and move the liquid. So we need to fill the the cavity here, or the cup or well, whatever you want to call it, with liquid. And we could do that in several ways. We could, start the emission, let it run for some time, and then adjust the speed here down to 0 with a keyframe. Another, and I think more efficient way here, is to make this circle emitter contain a volume. So you can have a specific volume set. And when you do that, the speed doesn't really matter, because it's not emitting particles constantly. It just creates the volume that you set it to, and when you press play, start the animation, it emits this volume of particles. So this is the perfect start for what we're going to be doing. Okay. So a few more things. We have the emitter done now, and we have the collider down here. But as you can see, let's just restart it. As you can see, there's quite a significant gap from the collision shape to the particles. And if we go into our collider and collider tag, we can go into our display tab here and press show collision geometry. This shows the actual geometry the particles are bouncing off of. So, and this is, if we turn it on and off, you can see it's quite a bit larger than the object itself. So to get it closer, we can do a couple of things. We can set in here the properties. We can set the collision distance to 0. And well, it doesn't really do much, it seemed. But the other thing we could do was to add a RealFlow volume tag. The volume tag helps fine-tune the collision detection of an object. And what we want to do here is go into the volume. We can see the collision geometry detail is set to medium. Let's set it to medium high. I'll just I don't know if you noticed, I'm just moving forward one frame and backward one frame to update the geometry. So this is a bit better, and then we'll also go to the volume mode here, turn off auto and set it to shell. It seemed to be the right way from the beginning here, but anyway, this is what you want to be doing, because this creates, as this is, I'll just take this off as well, as this is not an enclosed volume, it's just a surface. RealFlow needs to add a shell around this object to, I'll just take it off on again, needs to add a shell around the object to be able to calculate the collisions. Okay, so now it's definitely closer to the edge that we had here before. I'll just go in here. One thing you might notice is that quite a lot of particles are falling down and are not being detected or bounced from the collision. And this is one thing we're going to be fixing in the scene tab here. In the solver here we have the auto params, the automatic parameters here. And if I uncheck this, I can define my own substeps for the collision detection or the simulation. So let's just set it to minimum substeps of 4 and maximum 8, and let's see what that brings us. it's still some particles are still falling down. That's not too big of an issue in this case, and this might be better with the SPH solver, but it would take longer to calculate as well. So this is quite acceptable for what we're going to be doing here. Okay, and I believe the emitter for this case, let's just turn it down here and move it downwards, scale it up a bit, because we don't need the bouncing of the collision object here. We just need to fill the object, so as little bounce as possible. Okay, and what we are going to be needing now is to make this a liquid, or a liquid that starts out from the beginning of the animation. So we need to have this set as an initial state, and the way to do that is to simply go back to frame 0, let it run for some frames until things really settle down, which is just around here. Okay, this is it. Then we go into the fluids, and here we have the option of create initial state. So that's created now, and we'll check on use initial state as well. So now when we go back to frame 0, we start out with the particles as they are here right now. Okay, one thing I forgot in the beginning was that the caches here, they are saved as individual files at a specific location. RealFlow automatically creates a path for them, but I'd like to be creating my own, which is this one. So now we are saving the files, the cache files, in this folder. Okay, so I think we'll create initial state again and use it. Okay, so if we press play now, nothing really happens because the emitter has done its job. It's emitted the particles, and we have the initial state of the fluids as it is right now. So let's just hide the emitter because we're not going to be using that anymore. So this is the first part of it. We have the liquid here. Now we need to make the fluid here move, and the way we're doing that is by adding a sound effector to the collision geometry. So we'll want to be making it jump up and down. I realize the sound might be funky because it's not updating correctly, but this is what we want to accomplish. I'll just open another file because I have this one here. It's a bit easier and quicker to understand or explain here. So we have the collision shape, and then we have a sound effector. And the sound effector is usually associated with MoGraph stuff, but there's an option if we take the sound effector here and go into the deformer tab here. As from the beginning or a default, the deformation is set to off, but we can set it to object, point, or polygon. And that's what we're going to be using. We're using object here, and the next one we're going to be using polygon deformation. So now that we've checked this on, it basically works just like all the other deformers that we have here. So we need to have it in the hierarchy, and now the effect of this effector is affecting the object here. And first of all, we need to have a sound file loaded. I could, yeah, let's just clear this one and load sound. I have it, the webinar, After Effects project, assets, this one, open. And if we take a look, I'm just going to be opening the timeline now. As you can see, we have the sound effector, and we have several. Sorry. I'm going to be doing it again. Should have done this. So now we have the sound effector here, and we have a sound effector, or a sound effect entry here in the timeline. Yes, and if we go up here, we can see, I'm just going to start this. And I'm shutting down this one. Okay, what we have here now, just one moment. Okay, so what we have here now, this is the waveform of the music we have here, which we can see. And now we can have this probe that samples the sounds, or what is it? Is it the frequency or the loudness? I'm sorry, it's the loudness. So it samples this area of the sound. If we wanted to have it sample this, for instance, we get a completely different result, and we can add several probes to sample different areas of the sound file. So what I wanted to do was to get, come on, yeah, to get just this very regular curve here. So now it's bouncing up and down, and I'm sorry, I'm just stalling a bit here. I'm getting on with it. This sampling here, there are three different ways of sampling the sound effector: peak, average, and step. In this case, we're going to be using the peak sampling, which samples the peak of the sound. So when it peaks up here, it samples the highest peak of the sound, and then moves the object, or influences the object. So so this is the sample, and the parameters it's changing is this. Into the parameter tab, we have the Y direction. And, if I turn this up, it goes much higher. I hope the frame rate is frame rate at your place is okay, so you can see the movement. While this is running, we can try to examine some of the other things here. We have a decay tab here, or parameter, and right now the decay is set to 0. This means the movement follows the peak exactly. If I add lots of decay, it bounces up and then decays slowly downwards. This gives us some more subtle movement. As you can see, so it's jumping up and then falling slower down again. So this is just a short thing on the sound effector, and this is what's been done here. So we have the sound effector. The movement is 10 centimeters, and we have a decay of 5, and it's sampling this area here. One thing you might notice, which I've deleted just before in the other file, is the strength here. I wanted to, from frame 0, I didn't want any movement because I wanted to have this collision shape be at its original position. So I just animated the strength up from 0 to 100% within a few frames. So now we have this. We can add. I would believe the sound is quite funky. It is right here with me, but that's because of some update speed, because of the update speed. So so this is pretty much working as it should be. It moves the collision shape here up and down, and now we need to fine-tune the liquid so we get some more pleasing movement and something that is a little bit nicer. There are a few things I want to add. I want to add a daemon, a kill volume, and let's turn this down. I'm just scaling with the regular scaling tools, looking at it from the front and moving it just below here. And one thing to notice is that when we press play, everything disappears. That's because the kill volume or K volume daemon kills everything outside of the bounding box. So in order to make it work in our case here, we need to invert the fall off. And we can also delete any gradual fall off or linear fall off. So what happens now if we look at it from the front? Let's go back. It just kills all the particles that falls under the shape here, and it's basically just to keep the scene nice and tidy and let go of all the particles we don't need, the particles that fall down. Okay, and one more thing, or a couple of more things we're going to be adding is the surface tension, which I'm going to be really cranking up, and the sheeter here. The sheeter is it kind of fills the small cavities, the small holes, and make the mesh a bit more combined. So it keeps things together. It can be a bit dangerous to use in regards to speed, as you might see, because it's really slowing down right now. But it does give some pleasing results when we're working with it. I can just open this done here. This is the file after we've worked with it and everything's been cached. So you get this movement here of the first paint well. Okay, let's just go back to the other file as well, because let's say we are done with this one. We can go out and see the parameters on the final or the done file I just showed. But we'll want to add a new collider. This is going to be the thick red liquid that we saw in the animation. So a new emitter, a circle. Let's just look at this from the top. We need to move it over scale it down a bit, move it down, and we'll set a volume as well to this one. Okay, and as you can see, oh, it doesn't update now. Ah, stop. I'll just kill the shader here. Okay. Well, it doesn't show what I wanted to, but let's say I'll just rename this one emitter 01, emitter 02, and this is fluid 01. And you can see the emitter here is linked to the fluid 01, and the emitter 2 is linked to fluid 01 as well, but we don't want that. So I'll go up to the RealFlow here, fluid 02, and link this one to fluid 02. Delete this one and fluid 02. Okay, so now we have two different fluids within the same RealFlow scene here. So let's just turn this one off, and let's turn this one off as well. So now we have this one, which is much too faint. Let's see, fluid 2 here. This one will want a viscous fluid, and let's set this to 200. Okay, so we have the it's basically the same as before. We need to have a collider tag, and let's just copy these down from the first one, and let's see. Sorry. These ones have to be connected as well. So this one has to be connected with fluid 2. Okay. So yeah, now we're getting something. But as you can see, things are funky again. It seemed like they're not connected to any kind of gravity. And that's because these demons have to have the fluids assigned as well. So the gravity needs object here. So now this gravity and the surface tension works on both fluids here. Okay. This is more like it. Okay, so and then we have the viscous. In this way, we'll create an initial state as well. Create initial state, use initial state, go back to 0, turn off the. Oh no, sorry. This was wrong. Turn off the emitter here, and we'll do basically the same thing with the sound effector as we did before, but there are a few things that are different. Let's just turn this one off. Okay, and I'm going to frame around here, frame 180. As you can see, what's happening here is that the bottom of this collider shape is being moved. That is being moved by the sound effector. I'm using another part of the range here, the amplitude of the sound file, and we have a position set to 13 centimeters, and I'm using it as a deformer, deforming the polygons. And apart from that, I've also added a fall off, so it's only affecting the middle part of this cylinder, or this collision shape, sorry. And apart from this, another thing to keep in mind is that I keep the strength of this sound effector set at 0 until I reach the point where I want this liquid to start moving. So, and then I animate from 0 to 100% here. Okay. So, and this is basically it for this part of the animation. In here we have the final and cached files here, and I'm going to, as you can see, if we go back, we can see so now the first sound effector stops influencing, and the second one starts. And then we start again. Okay. One thing we need to do as well before we can render anything is to create the mesh that's actually rendering, and we'll do that by checking the selecting the fluid here, and go up to RealFlow and create a mesh. So this is measure 01. Go to the number 2 here, measure, get it down here, 02. So, and as you can see here, it's linked to the mesh 02, or a demo fluid 02, and this one is linked to 01. So let's just try this one. Let's build mesh. Well, that looks like a blob, and definitely not what we want to see here. So I can, in this mesh tab here, I can go up and create medium mesh, medium resolution, and I can turn on auto build, so whenever I adjust these parameters we get full build. This is more like it, you know. If we go down here, this is more like something we would like to see. So this one. Okay. This just needs a bit of a refinement, but it's you know, it's getting there. So if we smooth out the mesh, it definitely smooths out, and we thin it. That was maybe a bit too much, and then relax it. And you know, you can play around with these parameters and see what they're doing, but I think the important thing to understand is that the fluid or the simulation is one thing, and the actual renderable mesh, or the mesh we're going to be rendering, can be adjusted separately. So you can get the fluid like you want it, and you know, behave like it should, and then you can fine-tune the look of the mesh afterwards. And as I mentioned before, with the at some earlier point, the caching here, you can cache the simulation, and you can cache the meshes as well. In this case, the simulations, meaning the particles here, they're cached, but we haven't cached the mesh yet. So once this is being adjusted and everything looks okay, we can cache the meshes, so we don't need to recalculate every frame we go to. The second one here is basically the same. Let's go just very quickly, because time is running and we have a few more things to look at. So let's build this mesh. That can be a bit more blobby, because that's what this mesh is supposed to be. Is supposed to be some kind of thick acrylic paint or something like that. or oil paint or something. So we can adjust here and thin and relax and do whatever we want to until we achieve the right look of the mesh. Okay, so this is the first part of it. So we've gone through various settings of the RealFlow scene and the emitters, the fluids and demons as well. So let's build on this for the next one. And let's open. Yes. This might look strange. What we have now is we have the scene fluid object here. As you can see, this is from the first step here. Now I have this one, which is just a simple platonic object that I've deformed a bit. I'm just shutting off the palette here and turning on the collider shape. Okay, so this is going to be filled with particles. The first scene we had here was fluids. Now I want to create some granular particles, and I could continue using this and adding to this, but there's also the possibility to create a completely new scene structure. So let's just get this down. Okay. And now this is called scene granular. I'm speeding up here because we're running out of time, but this is called scene granular, and we'll go to RealFlow, emitters, and selecting a fill emitter. And this is placed, when we just had the one scene hierarchy here, things automatically fall into place, but now we have several. It's being placed here in the hierarchy, so we have to drag it to the emitter here. And if we look at the parameters of this emitter here, it's not connected to any scene or any RealFlow scene, so we'll have to drag this one down. So now this emitter is part of this hierarchy. These hierarchies, you don't have to have the objects here or the demons or whatever. They don't have to be within the hierarchy to work, but they have to be linked to the right elements. So this one has to be linked to the granular scene. So I have the emitter here, and it's a fill emitter, and the thing it's going to be filling is this platonic fill. So nothing's really showing up, but if I take the platonic and make it X-ray, and let's see if there's anything I'm missing. I think I need a fluid here, and this one again has to be connected here, and we have to connect the emitter. That's the other way around. So and fill ratio, fill volume. Oh, so there it is. I don't know if you can see it, but it's not very clear, but we'll fix that. So first of all, the fluid here, we'll set that to granular, and we pump up the resolution. Okay, so hopefully now you can see all these particles. I'm just turning it off. And now if I press, come on. now I want to have these fall down into the collision shapes here, so we'll have to again make sure that we use the right link. So we have the scene granular here, and we have the fluid, and we need some demons. And this might seem like a tedious way of doing it, instead of just using the original RealFlow scene here. But this way we can get the fluids fine-tuned and make them or cache them and kind of lock them off, so we have them done and don't have to worry about them. And then when we work on this one, we can the granular, we can work with this and we can cache and we can adjust without worrying if we're going to be accidentally doing something to the original fluids. So it's just the way I like to move or work, the workflow I like to be using. So let's see if we can. I'm not getting, sorry. I need to get the scene granular, I need to get the fluid here, and now it falls down. Okay, so this is kind of like we did before. I'm going to be taking this collider to another scene here, just to be able to show easier what's going on here. So let's see, when does it start? It starts around here, so around 3:40. It's okay. Yeah, I'm sorry, I'm running out of time. I'm speeding this one up here. So what I've done here is, now I've used the taken the sound effector. It's still being used to push something in one direction, the Y direction in this case. I've turned off the deformation, and I've added a cloner with a cylinder that's been slightly deformed to have a concave top here. And now I'm using the sound effector with, as you go down here, I'm using the step sampling. And by using the step sampling, we're using the entire range of these peaks here from the audio file. And to make everything a bit easier to see, I've also, in the cloner here, I've made it, here, in the parameter, I've set the color mode to on. So now it's using the gradient from the sound effector here. The gradient we have here is being used or applied to the cylinders as well, just to be able to show more clearly what they're doing. Okay, so, and again, I've animated the strength of this on at the specific time I want it. So this was quite fast, but this is the way that's been set up. And within the this one, I'll just open the done here, which is the file that's been cached. So we have the let's just see, we have the collider here. If we go down, you can see it's there, and this is being used to push these, and we don't need it that far, so hopefully you can see it on your screens as well. And the settings here, I ended up, it's granular, we have a resolution, density, and all these settings do different things, but it's very much, in my opinion, a matter of experimentation and seeing what works best. I think, from my point of view anyway, it's a bit difficult to exactly know what things are going to be looking like. So it's changing some parameters and trying to re-simulate. And seeing if it goes in the right direction. So, okay, this was the granular part of it. I'm sorry for going through it this fast. In this case, though, we're not going to, or we're not using a mesh. We're just taking these particles, which fluid consists of particles, and then like a regular particle in Cinema 4D, you can add the object here to the emitter. If you to the fluid here, and this is like a particle container. So all these particles will be emitted or all these particles are being represented with this geometry. Let's just see here. So it takes a little while to update, and that's why it's been turned off. Come on. Yeah. It has, yeah, there it was. So the granular, as you can see up here, it has 100 and almost 67,000 particles. So it does take a little while to render them in the viewport here. But it's pretty fast when you're just using them as render only. So you just see the particles in the viewport, and then when you render, it doesn't really take that long because it builds from frame to frame in the rendering, and that's pretty fast. So the last thing is something I'm going to be going through. Well, we don't really have time, so I'm just going to be showing you the final part of it and explaining what I've done. This is what it's looking like, and it's once again a new scene. I call it scene splash. I create this time here we have it, SPH, just to take that one as within the project as well. I create a sphere emitter, and the sphere emitter just has to turn on and then fall down, and then it's just a matter of seeing how many frames it takes for it to fall down, and timing the keyframing of the activation here to the right time. So at frame 599, this one is keyframed as not being filled, and at 600 it's being filled, and then gravity takes over, and things takes its course from here. The one thing I've done that is a bit different than the previous things I've shown you is that I've taken this collision shape, which is invisible, so it can be anything, and I've adjusted that, rotated it a bit, and adjusted the shape of it to get a more pleasing splash from it. So from just to try to art direct the way the splash is moving. So this is it for the RealFlow part of this. There's just one thing I'd like to mention as well. It's just a single thing here, because when we go to the camera main here, I have a camera animation, and you know, I think I'll do that with the end file that we have here. I have the camera animation here. It's a camera that's being followed along a spline and with a target, and then at the end it shifts to another camera with the stage object here. So but one thing that's really useful in the new version of Cinema 4D is the ability to view the depth of field. As you can see, we can see the depth of field here directly in the viewport, and that's really a big help. If I'll just delete the animation, delete track, okay, and I go up and change my camera settings so I really get a very blurry background, so it's easier to see. And now I can pick the focal point of the scene, and this really is a time saver to use it. So when I've done this, I've keyframed my focal distance. Then I turn it back off a bit so it's not this obvious, and then set out to render. So, and well, I'll say this is the complete project, and you're getting this apart from the cached files, because there's just too much data, but you're getting the scene files here, and you can do your own caching as well. Just remember to create an initial state first, and then run the simulation. But well, this is doesn't really work with the sound here, but this is the way through the animation. And we go up here, and the final bounce here. There are some things added in After Effects. I've adjusted some color correction and stuff, and stopped the animation at this point, and then made the color overlays that you saw in the actual file. I'm just doing one file. You see this color overlays from the corners here. It is supposed to be an art supply store, so lots of colors. And I've added a motion blur in After Effects. And even though I'm not showing the After Effects in this webinar, the After Effects files will come with the files you're receiving. And I've tried not to use any third-party plugins, so everyone with After Effects and Cinema, and with RealFlow, of course, should be able to go through the entire project if you want.